Yes, let me introduce myself. My name is Marco Ippolito, and I work at Nearform. We are a consultancy company, and also I'm a Node.js maintainer. I mostly work on security, and I've worked on the HTTP stack, um, streams, many parts of the Node.js project, and we're going to go through what are the most common vulnerabilities that are found in Node.js projects. So OWASP is it's an organization dedicated to security of web projects and web application in general, and they are recognized as an authority in terms of security. And every year they publish a top 10 list about the most common vulnerabilities that are found in web application. And so how these vulnerabilities are listed is basically through surveys from the communities and with some experts. OWASP every year publish a list of top 10 security vulnerabilities, and they are ranked by 3 criteria. So the first one is frequency. The most commons are gonna be rate higher, and also there is severity. So it means how much damage can this vulnerability cause. And then there is the impact. So for example, on how many people are affected by this vulnerability, how many machines. So these are the criteria on which the OWASP based this top 10 list, and we're going to see 10 examples of real vulnerabilities that we have fixed on the Node.js projects, and how you could recognize them and not make the same mistakes that we did. So let's get started. The first one is called server-side request forgery. So it's basically when someone provides you remote resource, an URL to some remote resource, and the server fetches it without doing sanitization or checking. For example, you all have third-party APIs that you call in your application, and this is if those APIs are untrusted or are not validated, they could lead to some disclosures of information. For example, well, this is the most common example is when you have a profile picture and you insert a URL, and the server fetches that URL without checking what's actually contained in there. So, for example, an attacker could pass localhost. So your server will try to fetch some kind of application that's running in the same environment, or could try to fetch some files like passwords. So if you don't validate the content of your third-party API that are provided by user or whatever, you're going to disclose information. And okay, but how can we prevent this? So first of all, URL sanitization. You don't want people to pass third-party APIs, for example, to file system. Like you don't want to allow people passing files, paths. And then you don't want to send raw responses to clients. If you are calling a third-party API, that could be whatever API, you don't want to pass back to the client the error stack or the raw response. You want to check what's inside the response and get the content and manipulate it, and then return just a simple error, but never disclose informations to the client. And this is the most important one. You always have to disable HTTP redirections when calling a third-party API that could be something trusted or not. You want to disable HTTP redirections because you don't know if you're calling a domain, for example, that domain could have been it could not be available anymore, and someone could be doing some sketchy redirections underneath. So just disable them. If the answer, if the HTTP response is 302, you block it. So this was number 10. It means it's actually the lowest in our top 10. This is common, but it doesn't have bigger impact. Now we're going to go to number 9. Security logging and monitoring failures. So this one is actually very common, doesn't have big impact, but it's one of the most common one. So we developers don't actually put much effort into logging because it's something that's boring, but it's very important to monitor high value transaction, especially in banking or systems where those transactions are relevant. So logging is fundamental in, for example, project like Mojalu, when you have high value transaction, logging is absolutely fundamental. And if you have a lot of logging, then you can see if there are actually problems or someone is trying to do something sketchy or trying to hack you. Let's see an example. So wait. So Node.js, actually, I've worked on it. It has a HTTP parser that's quite old. What does it mean? It means that has some kind of leniency towards invalid HTTP data. So this is an example where someone is smuggling HTTP request inside another one, and the Node.js parser actually think this is valid. So you are receiving one HTTP request, but in reality you are receiving two. So this was a real bug that we have in Node.js, and it has a CVE associated, and it's HTTP smuggling. But how did we found out? Well, the only way is to actually have proper logging. So when you are receiving a request, you always want to log what's going on. For example, this is just an example, when if we are validating our request and for some reason the validation is not working properly, we want to log what caused these failures so that we can analyze the failures and see, okay, someone is trying to do something sketchy, is trying to smuggle some HTTP request, whatever it's doing. Just validation is not enough. You need to log why it was not valid. And yes. So how to fix this problem? So always log all access control, for example, logins, user inputs has to be logged. So everything that the user has to input, you need to log it and to check if is it doing something, it's trying to hack or doing something that's not wanted. You want to make sure that logs are generated in a machine readable way, and that they are processed by, for example, a log manager that allows you to spot which logs look weird or which are errors or which are whatever what could be. So always log, for example, in JSON, and then have a log manager that can read the JSON files and work with them. And the final one is you need to have proper alerting. So if you have proper logging, then you would also need to implement proper alerting. So when you realize something's not as you expected, you want to escalate in some way, for example, ping a team member or alert whoever is responsible for security on the project. And this is very important. Number 8. This is also quite common. It's about software data and integrity failures. So this happens when we have some part of our infrastructure that someone can manipulate and change. For example, one very common example is if it's someone who does serialization and deserialization of data that's unsafe. So if a user provides data and you deserialize it in some way, for example, a JSON, he could hide something, some sketchy payload inside the JSON, and you would be vulnerable. This is a real case example with this library called Node serialization, and there is a CVE associated. This is the CVE. So you could, for example, smuggle an error inside the JSON, and when the library was trying to deserialize the JSON, it would throw this error and crash your server. So never trust user-provided data. Always perform some kind of validation and make sure that you use the proper tools to serialize and deserialize data. So yeah, ensure that unsigned or serialized data is not tampered. JSON is a very common one, but this could be also if you are downloading dependencies from whatever, or from the internet in general, you always want to check with the checksum file hash that is to correspond, or you want to use signed, you want to download signed dependencies or whatever it is, but it needs to be signed. Ensure that libraries and dependencies come from trusted repositories. So we developers have this tendency of download whatever is on the internet without just trusting that it's good and doesn't contain malicious payloads, but this is a bad idea. And always check digital signatures when they are available to verify that the software has not been tampered. This is quite easy. The most common one is to do the checksum of something and check it corresponds. But this is not 100% true, because if someone could change the payload, they could also change the checksum associated to it. All right, identification and authentication failure. So this is most common when you have, for example, a login or you use third-party authorization libraries. And it's the system inability to identify the user or validate that the user is actually who claims to be. We all know the game Among Us. It's a popular game where there is an imposter among the players. And so there is someone who claims to be someone else. And this is common in web application when we don't enforce a strong authentication. So the problem, this is also common when you, for example, the user passwords and emails has been leaked by a breach, or you don't actually enforce login timeouts after several attempts. So someone could just try to brute force the login, or could use passwords that has been leaked. And so someone is actually impersonating a user that's not himself. So first thing, always use multi-factor authentication. This is like the basis, the current standard right now. There is no reason not to use it. And most of the time, you can use a OAuth 0 or whatever provide public service that provides authentication, so you don't need to re-implement it from scratch. Always limit failed logins, because if you don't, someone just gonna brute force it at some point is gonna guess the username and passwords and log in eventually. Implement weak password checks. So how do we know that a password is weak? So OWASP, that we talked about before, they have a lot of materials that it's very helpful to enforce standards on web application. There is actually a standard to check if the password is strong enough. And you can just check on OWASP website and they will tell you, okay, these are the standards that your passwords need to respect to be considered strong. And you also want to rotate passwords every few months. the more, the better, obviously. And this is because if the password somehow is leaked, the window that an attacker has to perform the attack is much smaller. Let's move on to number 6. This, for Node.js projects, is a big problem. Usually, all the projects that are dependent on NPM are kind of the JavaScript environment moves very fast. Libraries release new versions every week. So it's very important to stay up to date with the new versions. Why? Because that new version could contain a patch to a CVE that has been published recently, or for example, could have some changes that are very helpful to your application. So never use libraries that are not maintained. One of the criteria of when using software is to check if the GitHub repository has been publishing patches and releases frequently. If you see that it hasn't been updated lately, you might not want to use that library. A big example is Express. That is the most common library on the Node.js environment, and it's not maintained since like a few years. So it just releases some patch like once a year. And that's a bad sign because it means if there is a vulnerability, nobody's going to fix it. So and this is another example from Undici. Undici is one of the libraries that we use inside Node.js. So it's a dependency of Node.js that actually has a version 5.8.0 that has an insane amount of vulnerabilities. So if you haven't updated the version, you're going to have like 2-3 CVEs associated. So always use a tool to monitor the status of your dependencies. It's very important to have Dependabot, Sneak, whatever tool you use, but use some tool. Don't do it manually. Actually, just for as a fun topic, in Node.js, until this year, we didn't have an automated process to automate dependencies. So I spent last year to create this system to constantly check every week new dependencies and update them. Automate the dependency update workflow, and it's exactly what I've been doing on the Node.js project. And it's very important. And always remove unused dependencies, because if you're not using them, but you're keeping them inside your Node modules, they could have some CVE, and you're never gonna update them, you're never gonna check on them, and you will have this vulnerability, and you probably don't even know, because most of the time unused dependencies, we just forget about them. We install them and they get lost inside these huge package JSONs that we have. So there are a few tools that I would recommend. Is my node vulnerable? Is actually has been made by a colleague of mine. It's quite reliable. There's Sneak vulnerability scanner. I think this now is like one of the best tools online. It's free, and it will tell you if that version of your dependency has a CVE associated, and it will update it automatically. And there is also Retard.js, which is the most legacy one, and it has been worked fine for years. So, all right. Number 5, we are security misconfigurations. This is most common on the infrastructural side of our applications. So when we have, we need to enforce that the configuration is actually safe. The prime example of this is leaving your password as admin. So you have a password and a username, but it does absolutely nothing. And so you always want to check that you are enforcing your security standards. And another example, more related to Node.js, is when you use cookies. We all use cookies in our application if it's a web application, but we don't sign them and we don't use the HTTP only flag. If you don't sign your cookies, anybody could read and change them. So they are absolutely untrustable, and it's very dangerous to do so. But you have the ability to sign your cookies with a key and to have the HTTP only flags that prevents userland scripts to access the cookie. So nobody can access the cookie other than the browser. Okay, how do we fix this vulnerability? Different credentials should be used in every environment. So most of the time we are lazy, especially in big corporate environments. We use the same password and we share the password with a colleague. This is a bad practice. Every environment should have different credentials, and the credentials should be stored somewhere safe, like in a password manager and not in text files, for example. You want to have repeated and automated and fast deploy environments. This means you might want to use tools like Terraform or whatever tool that allows you to repeat deployments. But why this is important? Because if we have the same environment every time, we can test it. So we can test it once, and we know that every time we install it, it's going to be safe. And it's very important to have environments that are repeatable and testable. And final one, we stopped working. Ooh. Okay, you want to test your configuration. So you want to create some integration tests, unit tests to make sure, for example, on cookies, if you sign cookies, you want to add a test that checks that the cookies are actually signed and not accessible. You do it once and you are sure that a hacker won't attack you or get sensible information from your application. Fourth one, this is a more general concept, and it's insecure design. So it's actually when we create our application, we don't put security first. Security is something that should be thought as as other than an afterthought, because if something happens, it's too late. So you want to put security first in your application design, and you want to make an architecture that is robust. And let's see. It stopped working. The next slide, please. Yeah, no. Okay, so this is a meme, and it's basically a web app, and we all put our hopes and dreams and prayers, but they should not be the fundamentals of our web app. They need to have robust foundation, and this foundation, the first one is security. Next slide, please. So how do we fix this? So model threats, it's something very important. So when we create an application, we need to identify which are the threats that we could be vulnerable to. And this is something that you do before thinking your architecture. You want to use unit, once you have created your threat model, you want to create unit tests to check that you're actually enforcing the security of your threat models. And this is something that you don't do it just once and then you move on. Our architecture changes with time. We implement more features. We had more components of our architecture. So we want to reevaluate the model threats every time we create something big. So this is something that it evolves with time. It's not something that you do it once and you're good. Third one, this is my favorite one. It's injection. This is very common. It's been in the on the market for a long time. The most common one is SQL injection. So injection is when an attacker is able to inject malicious payload inside our codes or our server. This is one of the this has a big impact because it potentially can leak our databases and our information. So yeah, the most common one is when we take imagine this query and an attacker adds this little piece of code and we actually run this code inside our SQL query. This is going to leak the whole table because it basically says whatever it's on the table, whatever respects this condition, 1 equals 1, return it. So it's going to return the whole table because you trusted user input. Never trust user input. This you need always to sanitize and validate whatever the user inputs in your application. And this is the rule number 1 of security. Especially for SQL injection, you want to escape special characters and never let the user supply the table name or the column name. You need to have those hard-coded in your application. Number 2, cryptographic failures. So imagine that our databases somehow gets leaked. So it's available on the internet. If we used a good cryptographic algorithm, even if it's leaked, everything is going to be encrypted. So it's useless for an attacker. But there are some cryptographic algorithms that are weak. The most common one is MD5. MD5 is considered a weak encryption algorithm. It's actually a hashing function. So don't use MD5 because if you go on Google and search MD5 decoder, it's going to take 1 second to decode your password. So how do we fix this? Use up-to-date and strong encryption algorithms. For example, SH1 is a hashing algorithm. It's outdated. It can be reversed, so don't use it. Use key secrets management. Don't push your key or secrets on GitHub. Obviously, you want to have some stored somewhere safe. For example, a vault, a secret manager, password manager, whatever, and disable caching for sensitive information. This is also common vulnerability because we actually do a lot to enforce security on our application, but then we forget cache. And cache contains the same data that our application has. So sensitive information, never cache those. It's better to lose a bit on performance than to leak sensitive information. And the last one, broken access control. This is the most common one and the one that has the biggest severity and impact of all that we talked about. So it's when a user can basically access data or perform action that he's not supposed to. So this happens when, for example, you log into to your profile area and then you can see the information about someone else. It's very common in web applications that, for example, do not have a strong authentication or authorization workflow. So how do we fix this? Deny by default. Always deny by default. Instead of allowing, you always want deny, and then you want to allow some actions that the user can do. You don't want to do the opposite. You want to implement access control once. So you use one access control provider, and that's it. Even if you have a big application, you don't want to repeat this kind of process because it's easier to add vulnerabilities. Tokens should be short-lived. Obviously, if a token gets leaked and an attacker gets a token, the short-lived it is, the better it is because it doesn't have a lot of time to perform malicious actions. And finally, log access control failures. So this is connected to the first one. Actually, the vulnerabilities are always connected one to another. So if you have one, you're gonna have like 2 or 3 of those vulnerabilities. So it's very important to have test and enforce security threat models. And that was it. You can find everything in my in this QR code, my profiles, social, and that's it. Thank you very much for listening.
Thank you so much, Marco. We're running out of time, but I'll allow maybe one question in the room. James?
Thank you, Marco. First of all, welcome. It's so great to have one of the core maintainers of Node.js with us in the room today. As you mentioned, we rely on Node.js very heavily. I think it's fair to say that we do in the Mojolib community pretty much everything you've said already. We use SNCC, we use Dependabot, CodeQL, as well as GitHub Secret Scanner to scan all our source code using static analysis. And our adopters, typically historically, we recommend that they perform penetration tests, commissioned external experts to come and penetration test the platforms that they implement. So I think most of the community that have been around for a while are very aware of this, and the automation that we have in our CI/CD to implement these kind of best practice recommendations. I think we've mostly got that covered, but what I would like to ask is, for a lot of folks in the room this week,
Hi people, it's glad to present.
Maybe they're coming to Node.js from other programming languages. Are there any resources that you can recommend, books or online courses, or even good blogs about general coding and design security practices that you could recommend to those folks?
Yes, absolutely. So there is a book by Liran Tal that's exactly about this one. And it's about security practice in Node.js. Now, I don't remember the name correctly, but it's a great read. And it basically covers every point. And also there is an open source workshop that we have created. It's basically the same top 10 vulnerabilities, but
Hi people is proud to present Women in FinTech, an innovative initiative under its Include Everyone program, as it continues to lead the way in the advocacy.
First person and see how to fix them.
Oh, that's fantastic. Thanks. If I can get some links from you, maybe after the
session. You can find everything on my GitHub.
Oh, fantastic. Thank you very much. Thank you, Marco. Once again, so a great pleasure and honor to have you here.
Thank you very much.